Bhaskar, if 3 are green, what's the thing? This is also noise. This is noise cancelling. Yeah. This one. Normal. This is normal. This is noise cancellation.
Recording in progress.
We will open the new one. This is this is the one, but I still. This total week this closer up. What about that new student? He is also not coming. That Venkata. It's today we are starting light, yeah? What is light? Sensation of sight. Sensation of sight is light, huh? Light is a sensation of sight, huh? So there is something called electromagnetic waves, EM waves. Huh? That means like the antenna signal propagation. It will be through that electromagnetic waves. So also there is something called electromagnetic spectrum. So when it comes to light, so there is something called. Do you know about wavelength? Wavelength. So when you see about, there is something called visible range. Visible range means only the things that we see must be in the visible range. Something called 400 nanometers to 700 nanometers. This is called visible range. Lambda is from 400 nanometers to 700 nanometers. It's called visible range. So if this one is out of this visible range, we can't see it. Only our human eye can see this visible range. Also, there is something called infrared rays, IR rays. You might have heard of IR rays, right? Sun will emit IR rays. Sun. UV rays also. IR rays. Okay. UV rays. UV rays means ultraviolet. So the visible range is from 400 to 700 nanometers. So human eye can only sense the rays only in this range. Okay. So also here light has different properties. So one is light can propagate like in terms of packets. Means light can be act like a particle. Also, light can act like a wave also. Light has these dual characteristics. So we can treat it as like a particle propagation also. We can wave propagation also. So in this chapter, we only see about the particle propagation. So this reflection. So in this chapter, we are seeing about reflection and refraction. Right? So this reflection and refraction are explained through this particle propagation. Particle propagation of the light. And there is something called diffraction. Same light has a property, which is one more property is called diffraction, which is nothing but bending of light. Light will bend. Refraction also bend, but it bends around the corner. So now refraction, why refraction is happening? Sorry, why light is bending? Because when light is traveling from one medium to other medium, right, the velocity will change. Right, if the medium is becoming dense, yeah, the velocity or the speed of the light will change. Because of that, bending will happen. So this is because of the change of the medium. But even the medium is not changing, but because of the corners, where are the corners, and light will bend. That can be explained through the wave propagation of the light. This is called diffraction. Okay. So, but in this chapter, we only look at the particle propagation of the light. We only look at the reflection and diffraction, which are explained through this particle propagation. Also, this is straight line propagation of the light. Also, you would have seen that laser light, right? Laser light. So generally, light travels in terms of as a straight line. Light travels as a straight line. So also in terms of particles. Okay. So this reflection and refraction are explained through this is straight line propagation of the light. Straight line propagation of the light. So today we will look at the reflection. Okay. So when you take a highly polished surface, such as a mirror, okay, and what will happen? Reflection will happen. That's why we see our face in our mirror, right? Because we are seeing our own face means it's a kind of getting reflected, right? So this is explained through the laws of reflection of light. The reflection of light is explained through laws of reflection. So what are these laws? There are two laws. The angle of incidence is equal to the angle of reflection, and the incident ray, the normal to the mirror surface at the point of incidence, and the reflected ray all lie in the same plane. Okay, all lie in the same plane. Can you are you able to visualize it? Visualize it. So when the, let's say if light is propagating in like a straight line, so let's say this is the plane. Okay, so and then so normal also will lie in the same plane, the reflected ray also will lie in the same plane, right? All these things will lie in the same plane. Okay, so also particularly here we see a spherical mirrors. Okay, we are interested in spherical mirrors. Also, we are interested in spherical lenses. So mirrors, this reflection is explained. Mirrors are governed by reflection. Lenses are governed by refraction. Okay, mirrors are governed by the laws of reflection. Lenses are governed by the laws of refraction. Also, we have the plane mirror, which is nothing but normal mirror. right? So in the plane mirror, the image formed is always virtual, direct. Because we see, when we see in the mirror, we see that somehow image is behind the mirror, right? But there is no object. But we see something is there behind the mirror. So it's a virtual. Also, we see as it is, erect only. Means we don't see like upside down. When we see in the mirror, our face is not like it's not upside down, no? Like head is up only, legs are down only. So it's erect. Understand what I'm saying? Why it's virtual? Behind it, but it's not there. We see that it is something it appears like it is somewhere behind, but there is no one, no? So it says that it's a virtual. Real means it should be there. Okay. And also it's a erect and the same size won't change. Size of the image is equal to size of the object. So what's the magnification factor? Magnification factor is 1, right? Because size of the object is equal to size of the. So for the plane mirror, the magnification factor is 1. It's a virtual, always virtual image, always virtual image. Sorry, same size and erect. So but when it comes to spherical mirrors, it may not be always virtual. It can be real also, and it may not be always erect, inverted also, and it may not be always same size. Can be magnification factor 1 or less than 1, more than 1. So this is how spherical mirrors are different from the plane mirror. Okay. So if you have any doubts, ask me. Okay. Hari, you should focus more. Okay. You're a good student. Focus. Okay. Nowadays you are learning good. Your learning is good. Okay. So we are focusing on spherical mirrors. So what does it mean by spherical mirrors? The surface, the outer surface will be it was taken by the part of the sphere. So it was taken from the part of the sphere. You know what's a sphere, right? So let's say if you take a ball is a sphere, or so if you take a football, that's also sphere. So what is the football? But it's a round, no? That's not a circle. Circle means, let's say if you take a, sorry, Earth is also sphere. So what does it mean by circle? Means if you take a ring, we play rings, no? That is a circle. Understand? But it's a 3D, no? Like yeah, exactly. Okay. 2D it's a sphere, 2D it's a circle, 3D it's a sphere. So it's a volume, right? It's a, so what is the volume of the circle? What is the volume of this? So understand these things. So when it is 1D means just a line or curve. So it has only length. But when it is a 2D, it has a length, also it has a area. Okay, it has length, also it has area. When you take a 3D, yes, also it has volume. Okay, so now what is the volume of the sphere? 4/3 pi r cube. Okay, volume of the sphere is, write down, hurry. Volume of the sphere is 4/3 pi r cube. What is the area of the surface area of the sphere? The surface area of the sphere. Surface area means outward surface. So 4 pi r square. Very good. Okay. 4/3 pi r cube. R is the radius of the sphere. Okay. Very good, Rohit. So what is the area of the circle? Pi r square. Rohit, you are very good. Yeah, you need to study more. Okay. You have to focus and I'm expecting you should be topper on your class, right? So after some days you should become a top. You have that capability. Okay. So what is the area? What is the area of the circle? Pi r square. Area of the surface area of the sphere is 4 pi r square. Volume of the sphere is 4 by 3 pi r cube. So what about the cylinder? You know cylinder? Sorry? Cylinder part is omitted, yeah? Now cylinder is not. So today we look at the spherical mirrors. So spherical mirrors means, so we have the sphere. Let's say take a sphere. So if we cut out, so spherical, when you take a sphere, it can be solid also, it can be hollow also. Hollow sphere means there is nothing inside. That's when you take a ball. Ball is just a surface, nothing inside. But when you take this throw put, that shot put, that is inside also we have that. It's not a air, no. Inside also we have material. That is called inside is solid. But inside is there is just air is there. Then it's called hollow. Okay. So when it comes to the spherical mirrors, so now we have the surface. Okay, let's say consider this is the sphere, not exactly sphere, but consider the sphere. So it's a hollow or solid? Hollow. So if I cut some of the part of the this surface, then it's a spherical mirror. I'm cutting some of the part of the surface and keeping it as that's a spherical mirror. Okay, so that's how, so we can see it now. Okay, so just the thing is because they are showing just in a 1D, but it's generally 2D. When you take a lens is not just a 1D, no. This is a lens, just 2D, right? So it is like you are cutting something from the sphere. It is like some surface which was taken from the sphere. Okay, that's how it's a spherical mirror or the spherical lenses. Okay. So, but for the ease of, we generally consider it as a just we'll show it in a just 2D. We are just showing it in a 1D. We'll keep later, yeah. So that's why it's just it was like a taken out of the circle. Can you see it? It was like a part which is cut from the circle. It was like a part which was cut out of the circle. Okay. So we can see concave mirror, convex mirror. What is the concave mirror? Concave mirror, this lining is inside. You can see the lining, this black lining, the reflecting surface, which is inside, which is called concave mirror. If the reflecting surface is outside, convex. Here, the reflecting surface is inside, concave. It is outside, convex. So if the reflecting surface is curved outwards, then it is convex. It's a curved outwards, then it's a convex. Okay. The reflecting surface is curved inwards, then it's a concave. Okay, if it's a curved outwards, convex. If it's a curved inwards, concave. Okay. So the easiest thing is you can take the spoon. The spoon, when you take it's like a, if it is a lining is the reflecting surface is towards the inside, that's a concave. But if it's the outside one, convex. Here. the center of the reflecting surface of a spherical mirror is a point which is called pole. Okay. The center of the reflecting surface of a spherical mirror. So you have this mirror, no? This is what mirror? Concave, right? First is concave. So the center part is called pole. Okay. The center part is called. Just remember the terms, yeah. Center part. So here the center part is here. Let's say. Okay. Here the center part is here. These are called pole. So just you remember the terms. Okay. What is pole? And pole is represented by letter P, capital P. Pole is represented by the letter capital P. So the reflecting surface of a spherical mirror forms a part of the sphere. It is part of the sphere. Okay. This sphere has a center, no? So this is called, this point is called center of the curvature. Center of curvature of the spherical mirror. Okay. If you take the spherical mirror and form a sphere out of it, then there will be center, right? The center is nothing but center of curvature of the mirror, spherical mirror. So it is defined by the letter, represented by the letter C, capital C. Okay. Hari, center of curvature, capital C. Okay. Oh, okay. And pole is represented by capital P. Okay. And so this center of curvature is part of the mirror or outside of the mirror? Outside of the mirror. Means it doesn't lie on the mirror, right? It is somewhere outside. Okay. This is outside of the mirror. So the center of curvature of the concave mirror lies in front of it. However, it lies behind the mirror in case of convex mirror. The convex mirror, it lies behind. The concave mirror, it lies. Class? Magnification is convex, no? Magnification or magnifying glass? Okay. That is Then you keep it in the paper and touch the paper, no? That is a lens. So generally it is coming from, light is coming from infinite, no? So when it's coming from infinite, which one will focus it? Convex or concave will focus? Right? When something is coming from infinite, which lens will focus? Convex. So that's a convex. Okay, Hari, good question. Okay. So now, what are the things we have defined now till now? Pole. That's it. So what's a pole? So is it a part of the sphere or a part of the mirror, or it's not the part of the mirror? Pole is part of the mirror. Center of curvature is? Now we are defining the radius. Radius of curvature. Which is represented by radius. So it's a distance from the center of curvature C to pole. The CP distance is radius of curvature, which is represented by capital R. So the PC is equal to the radius of curvature. So this is a line passing through the pole and the center of curvature. This is a line passing through the pole and the center of the curvature. This line is called principal axis. The line passing through the pole and the center of curvature is called. So now let's say, now consider this is what mirror? We can't say any mirror. Once we have the lining only, then we can say, right? Now it is concave. Okay, the reflecting surface. After that we have the reflecting surface, then only we can say it's concave or convex. Till if we don't know the reflecting surface, we can't say whether concave or convex. Clear? So this is pole. Okay, exactly from here, let's say if this is x, this is also x. Exactly same distance. Okay, and so if it is forming a, let's take extend it. This is forming what? Sphere. In 3D it's a sphere, 2D it's a circle. Okay, so where is the now the center? Here. Okay, getting? So this is called center of C. Okay, so from here to here the distance is R, radius of curvature. So the line connecting C and P is called principal axis. This is called principal axis. Clear? The terminology is clear? Want Rohit, what is being taught to you in the class? Physics light only? Refraction, huh? The reflection is over. Huh? Okay. So how are the classes here? Like, is it beneficial? Or Rohit, how much you need to pay for the, like in the school for the 10th class? You don't know how much you pay? Hari? 1 lakh? Huh? In the next class, Rohit, Hari, can you bring the protractor? Yes. Okay, you bring it. Then we can properly draw the lines. Then you clearly understand. the object is between pole to F and F to 2F. 2F is nothing but radius of curvature. R, right? R is equal to 2F. And if the object is after the 2F, then we can easily understand whether it's a virtual or it's a real. You can clearly understand. So then we can properly draw the lines. Next week, bring the protractor and okay. Then Kaushik is there. Kaushik.
Yes, sir.
Okay. Kaushik, next week bring the protractor, yeah?
Okay, sir.
Hmm? What thought? He's listening, don't worry. Hey, you look for yourself. Why are you looking for yourself? He's active now. So they are saying cautions like do not look at the sun directly or even into the mirror reflecting sunlight. It may damage. Hold a concave mirror in your hand and direct its reflecting surface toward the sun. Direct the light reflected by mirror onto a sheet of paper held close to the mirror. Move the sheet of the paper back and forth gradually until you find the paper sheet a bright, sharp spot of light. Means then we are focusing that light onto the entire light onto the paper. Then what will happen? Paper will burn. Hold the mirror and paper in the same position for a few minutes. What do you observe and why? The paper at first begins to burn, producing a smoke. Eventually, it may even catch fire. Why does it burn? The light from the sun is converged at a point as a sharp. Right, it can happen with a mirror also, it can happen with a lens also. But we need to properly place it. The light from the sun is converged at a point. So all the intensity is focusing at a one point. And what will happen? All the intensity of the light is focusing at the one point. Then a lot of energy is coming out, no? It will burn. Let's say it's like a 30 degrees of temperature is there. And that is being spread out. But now we are focusing everything onto the one point. Then it's like a more than 1000 degrees or more than 100 degrees or something. No. What will happen? If more than 100 degrees, burning will happen. Right? Burning. Burning means generally 100 degrees it's going to melting boiling point, right? So means it depends from the material to material. Some material will catch fire easily. Yeah, paper. I'm not exactly sure how much. So it depends on the material to material. General. So this point is the focus of the concave mirror. Focus of the concave mirror. Then the heat produced due to the concentration of sunlight ignites the paper. the distance of this image from the position of the mirror gives the approximate value of the focal length of the mirror, because the entire light will be focused at the focal length, right? That's why the distance will give you the approximate length of the approximate value of the focal length. So now we look at the ray diagram. Let's say if the light is coming from infinity. Okay. So this is what mirror? Okay, this is the reflecting surface. Okay. This is the concave mirror. So here is a, what is this one? What is this one? Principal axis, right? And what is this one? Center of curvatures. Not focus. Exactly center, no? Okay, it's a center of curvature. Focal will be somewhere here. Exactly C equal to F equal to R by 2. F equal to R by 2. R equal to 2A. So now sun means it is at the infinite distance. So at the infinite distance, all the rays will come as a parallel. Okay, all the rays from the sun will come as a parallel rays. So if this is the one ray, okay. So what will happen? This one passes through the clear. So and let's take one more ray. Again, this will also passes through. What? Hurry. Reflected and come backward, no? Right? This is the incident ray. This is the reflected. This is the incident. This is the reflected. Okay. Now take one more ray here. What will happen again? Pass through the here. This is incident. This is reflected. Now take one more. This one also passes through. Always we need to show the direction. Clear? So generally how to draw the reflected ray? But what is the direction? How to choose it? But if we don't know the focus, because here we are fixed the focus, and we are saying that it is passing through the. If you don't know the focus, so we need to follow the laws of reflection. What is the law of reflection? Diagonal of incidence is equal to. So for that we need to find out the normal. So how to draw the normal? From center to the surface, which is the normal. C to. So here this theta equal to this theta. What, Hari? From center to, we have center, no? C. Center of the spherical mirror. Center to the surface at which the reflection is happening. The point of incidence. So that is the ray of normal ray. We need to measure the angle with respect to the normal. So now here also, if you want to find the normal, you want to draw the exactly see theta are equal, right? Almost. So again, if you want to draw here, this theta equal to this theta. That's what we need to find the theta, and we need to draw the reflected ray according to that theta. Clear? Slanting also. Let's say this is the, let's say lining is inside, the reflecting surface is inside. For always we need to find the first pole. Okay, first mark the pole, then draw the principal axis, then find out the C. For C, what we need to do? Find out C. We need to expand this one. Expand the center point. Very good. Okay. Now let's just see this one. Okay, now you are saying sorry.
We should expand it to find the C rate. The exam they are saying.
What really? You can use it, right?
Exam they goes. Yeah. We can use rate and
Which exam? Here, school or out here? But these kind of things you used. Otherwise, how can you draw it? You can't draw it.
They say you should use normally recently we can draw. Like 2 days back.
Maybe those are like maybe it depends on the question also, no? Right. So it depends on the question also. Generally, you can use it because it's not okay. So now, what you are asking, ray is coming in a slanted way, like this. Okay. This is not a straight slanting, right? So now also to find out theta, first to draw this is theta. Now it will come like this. Again, keep theta and draw the line. Only the parallel rays will focus at the focus. Only the parallel rays will focus at the focal point. Standard lines, we can't say it. Sorry? It will come back. But like we can't say that they will focus at a point. Only the parallel rays will focus at the focal point. But we can draw the lines using this. Okay. Now let's say if one more line is coming like this, these both are parallel only, no? They are not parallel to the principal axis, but these rays are parallel. They will focus at some point. They will kind of focus because they're parallel rays. Understood this one? So now these rays are coming from where? Infinite. So to show infinite, we need to show the dotted rays at some point. Dotted means going on. Dot. Okay. So means they are coming from infinite. So this is for concave. Here, how did we draw the reflecting wave? Reflecting line, reflecting ray? From center of curvature, we need to draw the line to the incident point of incidence. Is that a point of incidence? Yeah, point of incidence. Point of incidence. Then we measure the theta. With the same theta, we again draw back the reflecting ray. Okay, that's the principle to draw the reflecting ray. Okay. Now we see for the convex mirror. Okay, for convex. For convex mirror, lining means the reflecting surface is outside, right? So now this one is what? Pole, yeah. This is what? Principal axis. So R will lie on the principal axis. Just I am approximately keeping the R, okay. Let's say this is C, right? I'm approximately keeping it, okay. So this is C, always C lie on the principal axis. Pole also will lie on the principal axis. So now, again we are taking the same case of it's a convex, but the rays are coming from the infinite. Okay. So let's say if one ray is coming exactly to the principal axis, then what will happen? This ray, how it will be reflected back? Now how to draw the normal?
So, to draw a normal, we want to say
Normal. Again the same thing, from C to the point where it is touching surface. Okay. So both are the lines are both are same, no? So then the angle is 0. So the reflecting ray also will be the same line. So it will reflect it back. Why it is reflecting back in the same direction? Because angle of incidence is equal to 0. That's why angle of reflectance also equal to. Now take one more ray. Okay, this is the incident. Now, sorry, from infinite, all the rays are coming from the infinite. That's why we are drawing as a parallel rays. Because it will be obviously in the middle, no? C equal to F equal to, that won't change, right? Okay. So now, how to draw the normal again? Mm. 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 But how? For that, always we need to draw the normal and find out the theta, center of curvature to is the point of incidence, right? Okay. Now this is theta is this one. Now you need to again same theta. Same theta is okay. So this will, if you extend this one, it will come to focus. Hari, clear? How I found out the theta?
normal line.
Hmm. from center of curvature to the point of incidence. Then we find out the theta. Then it will reflect back another direction, theta. Right? It's like a mirroring. Okay. So now, if the rays is coming from here, okay, if the ray is coming to here, now again we need to find out the normal. First of all, we need to find out the normal. Then only we can draw the rays. If normal is not known, you cannot draw the ray. Okay. Now again we need to, from the point of incidence to you need to extend it. Then this is theta. So again you need to take a theta. Okay, then extend this one. Okay. Understood? Hare. Reflected ray, you understood? All the reflected rays are diverging, no? But if you draw them, if you extend them, right. They will meet at the focal FF, focal point.
Okay. They are getting rays.
Yeah. So that's why we see a virtual. There's a virtual image, virtual focal point is virtual. Right? In this case. Yeah. Right. Because normally the focus is not happening, but it's appearing like it is coming. It is appearing like that. That's why we are extending. It's like appearing, but reality is not there. That's why it's virtual. Okay. So now again take one more. From the center of curvature, you need to again, from the point of incidence, you need to draw the normal ray, extend it. This is theta. Reflected ray again will be theta. Then if you extend it, okay. That's how this Boeing F is here. Okay. So this is it. Dot. Why we are keeping dots? Because the rays are coming from infinite. So here it's a virtual. Okay, it's a virtual. So the number of rays parallel to the principal axis are falling on a concave mirror. Okay. Observe the reflected rays. They're all meeting or intersecting at a point on the principal axis of the mirror. This point is called the principal focus of the concave mirror. Okay. How are the rays parallel to the principal axis reflected by a convex mirror? The reflected rays are appear to come from a point on the principal axis. This point is called principal focus of the convex mirror. The principal focus of the letter is represented by F. The distance between the pole and the principal focus of a spherical mirror is called focal length. It is represented by small f. So it seems like the rays are coming from virtually from F, from principal focus. In case of convex mirror, the reflecting surface of a spherical mirror is by and large spherical. The surface then has a circular outline. The diameter of the reflecting surface of spherical mirror is called its aperture. The diameter of the reflecting surface of a spherical mirror is called its aperture. Mn represent the aperture. Not a diameter, but it's a so this is here. If you take this is here to here, this is aperture. We consider is M, N, this is aperture. Actually, the Mn is aperture. Okay. What's the time? we will close in some time. Okay. Anyway, you took some 5 minutes. We will extend for.
Well, I didn't see, I didn't like our.
Huh?
I know. It's like. Last time.
We will close at 7:45.
Please, I have exam.
So what will do? 7:35? 7:40?
Only we do on that now. We end the next week, then they also they should come and
Understand? This is for you only, not for me. Huh?
see.
See, how is he listening?
At guess I woke up at 5 o'clock, I studied.
That guy is also studying only, no? He's also is not, but he is not complaining when he's having exams. He's also having exams many times. May not be today, but he's lot of exams he's also having, but never he's complaining. 140, right? He's never complaining. Good student. He also should be good student. Okay. Class is boring, huh?
No, I am tired and getting sleep. I am
Sleeping, huh?
sleeping.
Yeah.
But who can sleep?
The diameter of the reflecting surface of a spherical mirror is called its aperture. In figure 2, it is Mn. Okay. Let's say this is right. This Mn is aperture. Clear? Diagram is clear. This diagram is clear. So we shall consider only spherical mirrors whose aperture is much smaller than its radius of curvature. So what is the relationship between the R and F? R is equal to 2F. This implies that the principal focus of a spherical mirror lies midway between the pole and center of curvature. Okay, it lies midway between the. So tomorrow we see this image formation of the spherical mirrors. Okay, image formation. Not tomorrow, but next. So next week we have class on Wednesday only. Okay, Wednesday only. Monday, Tuesday math, Wednesday physics, Thursday math. Okay, this is fixed. Okay. So you have a spherical mirror. Can you get a spherical mirror?
So I guess they gave us
Gave in the class, huh?
how much they gave. People they gave. Every year they
Oh,
come in the field I have
can you check?
every chemicals related to science.
Which is school, Hari, you are? A?
G.
AG? What is full name? You are also the same school, huh? Oh, you are in which school? Chettinadu? Global school, huh? You? Chettinadu?
Yes.
Vidyashramam.
Yes, their school is in Paris.
Palace, huh? Separate, huh? So in one class, we see the image formation of the spherical mirrors. Next class, we see the mirror formula. Okay. And the next class, we see lenses, refraction, and refraction like introduction, and what about the convex and concave. And next class, we see the image formation of the convex mirror, like lenses. And the next class, we see the lens form. Right? And power, total there will be 6-7 classes, right? Four classes, huh? I think once we understand the mirrors, lenses is like, but it's about this is about a reflection, that is about the refraction. Okay, but the same thing always. What is the criteria here? Always first we need to draw the normal. How do we draw the normal? From the center of curvature to the point of incidence, and when you extend it, it will be the normal. Then you need to measure the angle of incidence. Then angle of incidence will be equal to angle of reflection. So this when it comes to reflection, but when it comes to refraction, no. So that is valid for refraction also, but their angle of incidence is not equal to angle of refraction. So that is related by that Snell's law, which is equal to n1 sin theta 1 equal to n2 sin theta. Sin r by sin r equal to n1 by n2, right? Snell is that not Snell's law, that is Snell. Snell shell. Snell shell. You are telling. That is not Snell. That is shell. That is what? Not Snell also. Oh, that's right. It's a Snell's law. Right. So there also we need to first draw the normal, then angle of incidence, then based on the Snell's law we need to draw the refracted ray. What are n1 and n2 there? Refractive indices. Refractive index n1 is refractive index of the medium one, where the incident ray is passing. So n2 will be medium 2, where this refracted ray is going. Right? Those are n1 and n2. I is angle of incidence. R is angle of refraction. Okay? Angle of refraction. What is the mirror formula? 1 by f equal to 1 by 1 by f equal to 1 by u, 1 by u plus 1 by u. Then what is the length formula? 1 by f equal to what is u? What is v? Image distance. F is the focal length. What is the magnification factor? Oh yeah, it depends on the h dash by h is same, but v by u or minus v by u, it will change from mirror to lenses. For mirror it is minus, for the lens it is plus v by u. Okay. So actually this light is very easy. Okay. Hurry. Some are also easy. First you need to understand this concept. how we are drawing the normal. If these things are clear, then you will be able to draw it easily. Okay, it will be clear to you, don't worry. Okay, we'll do it well. Today we'll close, huh? Because you are requesting, no? Huh? 7:38 only, no? 2 minutes, huh? Maths class, next class, that sums you need to solve, no? Already, I think I already solved every sum in the class itself. I think I solved everything in the class itself yesterday.
No.
Yeah, I think main things only I solved. Remaining are just easy only. The remaining questions are easy only. Like just if sin A equal to 3/4, what is cos A? What is tan A, cot A? These are easy. Okay. You're understanding, Hari? Physics, math also? Physics also? If something is not clear, you need to ask. Okay. Then let's close for today. Okay. Huh? 1 minute. Gracious. Like,